In our notes for today, we're going to talk about logic. So today we're covering logic and conditional statements, which are chapter 2.2 and 2.3 in the book. For our warm-up, we're looking at, are these arguments logical? So it says, if the street is wet, then it just rained. And we see that the street is wet, so we conclude that it just rained. So think about that. Is that logical? So I would say yes and no. Like, it logically follows from the thing that we said. If the street is wet, then it just rained. And the street is wet, so it must have just rained. You obviously can see that that's not true, though. Somebody could have just spilled a drink. Somebody could have like a leaking air conditioner or something, right? There's lots of reasons the street can be wet. Somebody could be watering their lawn and it gets onto the sidewalk or the street. So we know that the street can be wet when it didn't just rain. So the problem here is not the logical connection. We made a logical conclusion from the premises, but the premise is not correct. So a lot of times when people say something is illogical, what they're really doing is challenging the premise that the logic is based on. So this connection is, I would say, logical, but the premise is false, so it makes the conclusion false as well. So the second one is very similar. It says, if an animal is a bird, then it can fly. And penguins can't fly, so penguins aren't birds. Same problem here where the premise, the conditional statement that we gave at the start that said, if an animal is a bird, then it can fly, is not entirely accurate because there are birds that can't fly, obviously, like penguins. So we have to make sure that when we're applying logic that we are using valid premises that we are basing it on. So to start our notes today, we're going to talk about the concept of truth. We just looked at some cases where something was not true. In math, we say that everything has a truth value. Things can be true or things can be false. We don't really have any in-betweens, which is one nice thing about math compared to actual real life, where things are much more complex and complicated and can't necessarily be established as true or false so definitively as we can in math. So if I say, let me make a note page here. If I have a number 2 and I say 2 is even, that is true. No real debate, that's just by definition, it is a true statement. So when we're talking about arguments, we usually are going to be using letters like P and Q. P and Q are shorthand for statements. So I could say 2 is even and define that as P. In the previous slide when we looked at the examples, I could say penguin, or what was it? I forgot already what it said. Let's go back. So it said, the street is wet and so it just rained. So I could say that the street is wet. That is a statement, and that statement can be true or false. So instead of writing that repeatedly, I can just use P as a stand-in for that. And so whenever we want to refer to the idea of the street is wet, I can just say P. Same thing if it just rained. So it just rained. I can use Q to refer to that second statement. And we can make judgments about the truth and untruth of P and Q and talk about their relationship to each other without having to write out all those words every time. So if P is true, then we write P, but we can also have the negation of that. And the negation of that is basically the opposite. Well, actually, that doesn't mean P is true, sorry. This is just the statement P, the street is wet. The negation of the statement is basically saying the opposite of that thing. We use this tilde character to represent not. So if I put not P like that, that's saying the opposite of P. So if my statement is the street is wet and I write not P, that really means the street is not wet. The street isn't wet. And see how not P is a lot easier to write than the street isn't wet. Same thing with it just rained. I can say Q represents it just rained. Not Q then would represent it didn't just rain. I can then take these things and combine them in ways that say add them. So conjunction is adding statements. Or subtract them, or not really subtract them, but well, let me show you an example. So if I said P and then this caret symbol, this little like upside down V, this means and. So I create a conjunction. This says P and Q. So if I wrote this with these statements, it would mean the street is wet and it just rained. So that would be combining those two statements. I can also combine negations. I could say not P and Q. That would mean that the street is not wet and it just rained. So this is just making statements, right? It's just observations, basically. So the street is not wet and it just rained. So that would be how we'd write that. This is called a conjunction. So kind of like conjunctions in English, it combines things. Like and is a conjunction word, right? It combines two things together. So the other thing we have is a disjunction. So if I have P and then I put that right side up V kind of symbol and Q, then this means P or Q. So if I wrote this, it means the street is wet or it just rained. And or is kind of an ambiguous word in English. So we have what we'd call an inclusive or and an exclusive or. So inclusive or is when in English we would say and or. So I could say I am an adult and or a teacher, and that would be true, right? I am an adult and I'm a teacher. So in math, if I said the street is wet and it just rained, that could mean both of those are true or just one of them is true. So we, in English, would use maybe the phrase and or to mean this. In math and programming and logic, the other idea of exclusive or, meaning they sometimes write it as X or. So exclusive or would mean that it's only one or the other, but not both. So if I said P or Q in that context, it would mean the street is wet or it just rained, but not both. So just to be clear, we're not talking about this one, not exclusive or. This symbol here means basically and or. So it could be P, Q, or both. Okay, I know that sounded confusing. So these ideas of values and their opposites and combining them logically is hugely foundational in like programming and logic. So if you ever do anything with programming or coding, you're probably going to run across things like this where you're dealing with this kind of stuff. So a way to kind of look at these values is in something called a truth table. So I want to do an example that will kind of help us to see how this works. So I want to evaluate, so let's make two statements. We'll say P is a male and Q is an actor. So we have P as a male and Q as an actor. And I'm going to come up with 4 examples here. So let's start with Tom Cruise. Then how about, I don't know with Tom Cruise, I just think of Nicole Kidman. So I'm going to put Nicole Kidman because they were married for a long time. So those are 2 examples. And then I'm going to put Barack Obama and Michelle Obama. Okay, so to make a truth table, we make columns for any values that we need to know. So we're going to put a column for P, and a column for Q, and we're going to evaluate for each of these people, is this thing true or false? So for Tom Cruise, remember P is a male, so yes, he is a male. Nicole Kidman is a female, so that would be false. She is not a male. For Barack Obama, he is a male, so we would put T, and then Michelle Obama, we would put false. So that's just recording for each of those people, is the thing true or false? Then we'll do the same for Q. We say, are they an actor? Tom Cruise is an actor, so that would be true. Nicole Kidman is an actress, so that would be true. Actor, actress. Barack Obama and Michelle Obama are not actors, at least not as their main thing they're known for, so we'll put those are false. Now what we can do is we can evaluate other statements based on these. So we can make like conjunctions and disjunctions. So if I wanted to make another column that evaluated not P, remember that's the opposite of P. So rather than going back and thinking about each of the people and their statements, I can just refer back to this P column and say it's the opposite. So is Tom Cruise not a male? That's false, right? But that's harder to think of than just it's the opposite of what this value is. So I'm going to reverse all of my truth values, and that's going to tell me that, so like for Michelle Obama, is she not a male? That's true. So that's lining up. I can do the same thing with not Q. I can make a column for the opposite of Q, which will just be FFTT. And then I can make, so these are all just obvious, right? But then what I can do is I can make conjunction and disjunction columns. So if I wanted to see, is the person a male and not an actor or actress? So I'm looking for where is P and not Q both true. So I'm going to ignore these two columns. I'm going to look at the first and the fourth column. And if they're both true, then P and not Q is true. So Tom Cruise, I have a T and an F, so he's not both of those things. Nicole Kidman, false, false, not both of those things. Barack Obama, true, true. That says he is both of those things. He is both a male and not an actor. And then Michelle Obama, F and T, so that's false because it's not both true. And then, so this would be an example of a conjunction. And we could make a conjunction of any of these things. We could say P and Q, P and not Q, Q and not P, Q, yeah, right, we can combine them in any way. The second one we're going to look at is going to be a disjunction. And I'm going to do a disjunction of just P and Q. So we'll do P or Q. Remember that this or means that at least one of these is true. If they're both true, that's okay. If either of them is true, then we're going to say it's true. So Tom Cruise, we have a true, we have two in fact, so that is true. He is a male or an actor. Nicole Kidman, we have a true, so it's true. She is a male or an actress. Barack Obama, one true, so it's true. He is a male or an actor. And Michelle Obama, two falses, so she is not a male or an actor. So that's how truth tables work and how conjunctions and disjunctions work. That's kind of just putting the values together. So hopefully that makes sense. We don't need to be overly into this, but it's a really important topic, like I said, for computer programming, computer science. So I think it's important to like everyone to have a little bit of understanding about how this idea works. All right, I'm going to actually break this video to two, so that will cover logic